Hi everyone, welcome to our topic, Designing IC Families. By the way, I'm your reporter, Christine Joy Vigleo, and this report is part of my class requirement for the Electronics 2 lecture class. So in this topic, we'll be diving in the few subcategories or topics later on. First one is we need to have a refresh if hindi pa naman natin alam o hindi pa natin na-discuss what the integrated circuits are, ano yung IC or IC family, and bakit natin kailangan pag-aralan or why are they useful in the first place. Second one is if you are trying to go into the industry where you need to design or manufacture yung mga integrated circuits or yung mga products that are made of integrated circuits or my component na integrated circuits, we can also talk about the landscape, the considerations, yung mga architectural considerations, or the things that you actually have to do if you want to be in that industry. So, if mag-intern ka sa mga factories that are creating ICs, ano yung mga kailangan mong gawin para hindi ka na mahirapan when you already go there. So, we need to discuss about that one ngayon pa lang so that you'll know what you need to do or what are expected of you in the future. The third topic that we need to kind of subtly discuss lang is yung mga challenges and opportunities that this certain topic will be able to give you in the future, or yung pagde-design mismo ng IC, kung ano yung mga mabibigay niya, mga opportunities in the future, and also the challenges. Just a quick recap lang siguro, we're not dive deep into that one kasi I'm not an expert in the field doon. So, konting ano lang, refresher. Next one is yung paano ba ginagawa yung mga ICs. So, what are the steps that are usually taking place whenever we fabricate ICs? Ano mga nangyayari, or if gusto niyo mapanood yung pinaka full details, saan yun siya, yung video that could lead you into, having a preview or step-by-step walkthrough ng each process. So, yung akin lang is yung overview lang kasi medyo mahaba siya if it's gonna be talked individually. Yung parang comprehensive yung pagdi-discuss, medyo mahaba siya. And then yung last one, I'm just going to give you a few examples of the formula that you need to memorize just in case masali siya dun sa board exam natin. At least we already are aware of what we need to study. Also, sample solutions of those specific problems and formula. So, I don't know, konti lang. And these are some of the mga keywords that you might want to explore deeper on your own if you want to. So, again, we'll be talking about the IC family design. So, kung paano mag-design, fabricate, etc. Or what are the usual problems and key factors that we consider in designing IC families. Last time, we did a seminar, although hindi ko nalagay yung picture dito. We had a seminar. I think it was led by MSU Ligan and some of the designers mismo ng mga integrated circuits, mga microchips, etc. So, some of the information here are taken from there on the lecture that they had, but not comprehensive kasi last year pa yun. So, let's talk about first yung sa integrated circuits. Integrated circuits, for example, katulad nito, this is an example of an IC, pero yung 8-pin na IC, marami kasing pins yung IC, may I think I saw a 10-pin IC, and then yung may 14, I'm not sure if there is a 14-pin. Tagal na kasi ito, nasa logic class pa namin to, logic circuits. So, by the way, one of the prerequisites, if you want to learn more about IC circuits and yung mga building blocks niya, is you need to refresh your logic circuits concepts or knowledge, or yung ano yung mismo, yung learning mo noon doon sa topic na yun. If na-take mo na siya, if hindi naman, maybe you're taking it now, so you can go back there for the prerequisites of this specific topic. But for an example of the integrated circuit is this one. So, ang parts ng integrated circuit natin, we have the ground, trigger, output, reset, ang power supply, input natin, ang VCC. Actually, hindi yan siya power supply. Yung sa collector to parang collector to ground, power natin yan siya. And discharge, threshold, and control voltage. So, those are some of the parang ports of the IC. So, ito yung integrated circuits natin. May dalawang klaseng components. Actually, tinawag siyang active component because it's doing something with the electricity. Meron ditong diodes and resistors. Yung diode is like a highway, one-way na highway natin. And transistors are the traffic controllers. For example, pwede ring amplifier. So, it depends kung ano yung use niya. They switch electricity on and off. They give the signal. Yun yung parang use ng transistors. Yung passive components naman natin, they're like infrastructures ng city. They do support the workers, pero wala silang ginagawa by themselves. They cannot move the electricity themselves. So, we need the active components for that. So, yung mga passive components natin are the resistors and also the capacitors. Yung mga resistors natin are like speed bumps, kumbaga, that they slow the flow of the electricity. And yung capacitors naman natin, yung parang small towers or substations. They store the electrical energy or electricity, and whenever we need it, they release it. So, yun yung use ng capacitors natin, especially in ICs. So, bakit nga ba natin kailangan mag-invest or malaman or mag-design, this is for everyone, ng integrated circuits? Well, I have listed here, I think, 6 reasons. Number 1, kasi mas maliit siya. It's smaller compared sa ibang mga equipment noon. And IC actually made way for our telephone, yung mga malalaking telephone natin, to become very small. Yung cellphone na siya. So, nagkakaroon tayo ng smartphones, etc. So, parang yung mga ICs natin, they're very, very small. Unlike before na mga components natin is malalaki, IC actually made them smaller and more compact. Tsaka yung pagpaprocess kasi ng IC, so paggawa ng IC, medyo massive and mas maliit siya. So, it's cheaper to actually make them. Katulad lang ito, nasa picture, they're like Lego bricks or blocks na halos maraming magkakaparehang parts but they're building something, kumbaga. So, they have improved system reliability. Solid kasi yung Lego. Ito yung pinaka pwede kong i-compare just in case yung IC. Solid kasi yung Lego. Maliit lang siya pero solid siya, and it can create something big or it can create many functions. Marami siyang functions kahit na pare-pareha lang yung mga individual functions ng Lego. So, katulad ng mga ICs natin or IC families na tinatawag natin, may mga IC na magkakapareha yung kanilang function or kumbaga parang hindi naman magkakapareha pero magkakalapit. Some are used in power performance, improving power performance. Some are used as switches, etc. Some are used in the mobile phone industry. Some are used in other industries. Okay, marami tayong ICs that have almost the same functions or kahit nga the same functions talaga, but if we put them together, they can do many things, many unique things. So, yun yung isa sa mga pwede nating isa sa mga rason bakit ko siya kinumpare sa Lego. So, it gives us, ito yung mga match devices, all the same type of Lego block are exactly the same pero nakaka-create sila ng maraming bagay or functions. It also has better performance compared sa mga dating gamit natin or equipment na medyo malalaki, and increased operating speeds or reduced power consumption kasi nga yung mga topic natin last time, yung mga current mirror, mga feedback amplifiers natin or feedback circuits natin are already applied. So, yung mga magagandang applications or benefits nun, it's already applied here in the IC or integrated circuits. So, if you wanna know more din, ano yung mga iba't ibang klase ng IC families natin. So, I actually created a logic family picture or map. Let me just see if I can open them. So, as you can see here, we have the logic families. It's divided into 3. Actually, usually sa mga lectures, it's only 2. We have the bipolar, logic family, and unipolar. So, these 3 families, yung bipolar logic family natin, we can think of them as three different ways kung paano tayo gumawa ng mga switches. For example, the first one is yung bipolar logic family. It's our basic. Yan, yung mga basic switches natin. They're usually using BJTs as switching devices. So we have two types of bipolar logic family, the saturated and the unsaturated. Yung mga key characteristics nito, kasi nga yung bipolar transistors, they control yung current flow using two types of carriers. The first one is yung electrons natin, negative charges, and yung holes naman yung second. So positive, yung parang hindi naman siya positive charges, but yung the absence of the negative charge. Yung key characteristics ng ating bipolar logic family is historically they are faster compared sa itong mga early MOS natin. You have the unipolar logic family. Compared with this one, they're kind of faster. Okay? They also have a higher current drive because BJT can provide more output current. Mas useful siya sa pagdadrive ng mga ibang gates, yung higher current drive natin. Ang sa bipolar logic family, they also have lower input impedance, meaning mas nakukuha niya, they tend to draw more current galing dun sa preceding stage. So, for example, if meron tayong circuit beforehand, mas nakakakuha siya ng mas maraming current from there. They also have higher power consumption, itong bipolar logic family natin. They generally consume more power, ito, compared dito sa kabila natin. We have the CMOS, ito, yan, CMOS or the BiCMOS. They're usually, itong mainly CMOS, they're usually nagko-consume ng mas maraming power. So, when it comes to power consumption, mas prefer mo yung unipolar logic family kumpara sa bipolar logic family. However, if yung mga functions na kailangan mo is more on the output current, yung pagdadrive na pagkukuha ng mas maraming current with the preceding one, and faster yung switches or switching, dun ka sa bipolar logic family. So, for example, we have here several types of saturated na bipolar logic family logic ICs. So we have the logic transistor logic. So we have RTL or resistor transistor logic. We also have the direct coupled. Ang RTL kasi ito, sabi dito is it's using resistors and transistor. Kaya nga resistor transistor. So it has limitations sa speed tsaka sa fan out niya. One of the characteristics of ICs, by the way, yung fan out. Aside from marami pa siyang characteristics, i-mention ko na lang maybe later or during the class discussion. And then we have yung parang siya, it's simple. Simple lang yung RTL natin. Resistor, transistor lang. So, merong mga limitations konti sa speed tsaka sa fan out, which is sometimes an important characteristic in considering ano yung mga kailangan sa IC design. Yung DCTL natin or direct coupled transistor logic natin, kumpara natin ito sa diode transistor logic, by the way, they're different. Okay, magkaiba yan sila. Yung sa diode transistor natin, improve lang siya kumpara sa RTL kasi dinagdagan siya ng mas maraming diode. So, mas maganda yung pag-fan out niya and mas immune siya sa noise. So, hindi masyadong nasisira yung signals natin. So, mas high speed lang yung ECL, yung unsaturated natin, kumpara dito sa mga saturated bipolar logic family natin kasi nga, nagko-consume sila ng mas malaking power. Anyway, dito sa unipolar logic family natin, they're mainly composed of MOSFETs, ayan, the P-channel MOSFETs, N-channel natin, tsaka yung magkasama, N-channel and P-channel, we have the CMOS. Pinag-aralan natin at I think na topic ni Jover. And then we also have the more enhanced pa, pinag-combine yung bipolar tsaka yung CMOS natin. So we have pinagsama niya, ito kaya nilagay ko siya sa gitna. Pinagsama niya yung bipolar natin and with the unipolar logic family natin. So mas siya, mas compact, and also mas high speed siya. Yung high speed ng dito sa bipolar plus yung low power characteristics ni unipolar, pinagsama dito sa BiCMOS. So, the best of both worlds yung BiCMOS. Hindi siya mostly nadidiscuss sa mga YouTube tutorials kasi nga itong basic combination lang naman siya ng basic ng dalawa. So, the best of both worlds. Now, these ones I have mentioned, these are actually digital ICs. Meron pa tayong tinatawag na analog integrated circuits. Dito tayo kanina, we have two types of integrated circuits. Aside dito, we have analog IC and digital IC. And yung combination pa ng dalawa, which is the mixed signal integrated circuits. So, yung digital IC gumagamit ng binary signals. Ang sa analog IC naman, gumagamit siya ng continuous signal. So, it's used in amplification, filtering, signal conditioning, tsaka power management. Yung sa digital IC naman, ginagamit siya as part ng mga processors natin or microprocessors, yung mga logic gates, yung switching, memory chips, and yung mga sa, katulad nung sa Arduino, etc. Yung mixed signal integrated circuits natin, kasi nga, it has component na digital, meron ng mga analog IC, they're used for data conversion. I think sa communications na topic natin, sa subject, you try to convert the analog signal to digital and digital signal to analog. So, overall, ito yung mga digital and analog ICs natin. And these are the specific, kung gusto mo malaman ano yung mga analog circuits natin, we also have the following. We have operational amplifiers. For example, yung LM741 natin na ginagamit natin in, yung mga speakers, yung voltage regulators natin, the 78XX line and 79XX lines. Yung mga comparators natin, if we try to compare two voltages, analog switches, and multiplexer, sa mga pagra-route ng signals natin sa data communications. We also have data converters, yung sinabi kanina, where you transfer one form of signal into another. So, from analog to digital, digital to analog. Radio frequency ICs natin, they are used for high frequency communication systems. Ang high frequencies natin, I think, is on yung mga satellites, towers, ano pa ba? Nakalimutan ko yung specific ng high frequency, pero may super high and very high pa kasi. So, we have audio amplifiers. They're used for trying to adjust the volume, to enhance the volume of audio signals, and yung mga timers and oscillators natin. So, lahat-lahat yun siya are analog integrated circuits. And we also have here some examples if you want to see the specific transistor logic circuit mismo, yung RTL, DTL, TTL, ECL na sinabi ko kanina, yung PMOS, NMOS. Hindi ko siya nalagay lahat, pero ito yung mga common na integrated circuit families and their schematic. So, we have here design considerations. Now, yun yung mga basics natin kanina. If you want to go into the design industry or design part ng electronics, engineering, so we have here the following things that you need to consider. Number one, if you have to identify or to define ano yung target application and market na mga ginagawa mong IC. So the first one is you need to identify the needs and then kailangan. So mobile devices or mobile industry, sa automotive, sa industrial controls or manufacturing, sa high performance computing o mga computers, mga microprocessors, mga supercomputers, yung mga gaming devices, dyan ba yan? So, iba-iba yung mga demand, mga kailangan mong specifications based on that specific demand. Market analysis naman, ito yung medyo techy na part. So, key performance requirements, meaning gano'ng kagaling, ano yung mga goals mo, anong kailangang specs ng inyong mga IC na gagawin. Cost sensitivities, hindi naman kasi lahat nakaka-afford yung pinakamagandang IC. So, depende sa budget. Ayan. Ano yung mga trend, ano yung mga parang market trend ngayon sa specific IC, and can you beat the cost of that specific IC? So, marketability. And then we have here power consumption limitations. Yung product requirements or PRD, ito yung mga kailangan mo i-provide sa documentations just in case you want to sell your IC, you want to market your IC. So, number one, yung mga hinahanap nila, especially with the engineers, tinatanong nila, is yung mga functional specifications, yung performance target natin, especially with the speed, power, and noise immunity. Ito yung mga isa-solve natin, by the way. Operating conditions, voltage, yung temperature, where the IC is operating well, packaging requirements natin, and yung mga goals natin sa cost. We also have here the second thing that you need to do. You have to choose your underlying technology. So there are different types of logic families, as I've mentioned kanina. So you need to consider ano yung mga kailangan mo, ano yung mga available na logic families, etc. And ano yung mga necessary dun sa gagawin mong IC. So, for example, you have to consider yung advanced CMOS variations. For example, if you need low voltage or high speed na mga ICs. So, again, fundamental logic family natin, we have TTL, CMOS, ECL, and BI. CMOS, yung mga pinaka basic natin na ginagamit. Especially if it's based on record speed, power consumption, noise margin, and integration density. Yung integration density natin, nasa-solve, ito siya. But I will not be able to show you how to solve this one because this, I think, is on the logic circuits advanced classes. Ang process technology node natin, kailangan natin pumili ng sakto lang na semiconductor manufacturing process node. So, node meaning gano'n ka liit or kalaki, or yan, may mga sizes tayo dyan, 28, 14, or 7 nanometer. Kasi, the smaller the nodes, they offer the higher speed, kumbaga, at saka density, pero mas napapalaki yung cost, as usual naman. Analog mixed signal considerations natin, we also have the transistor types, just in case, yung mga components natin. And of course, we also have yung specialized process technologies natin. Kasi nga mixed siya, you also have to make sure na yung isolation techniques between the analog block natin and yung digital block natin will not, parang disturb each other. Yun na lang yung word na gagamitin ko. Disturb each other. And the next one is yung architectural design nyo. So, paano yung pagpapartition mo from the overall system papunta sa mga individual IC mo. Ang modularity, meaning magagamit mo ba yan siya? How well can you reuse that specific IC? Ayan, yung sa mga para hindi ka na mag-uulit-ulit na mag-design, depende sa ito naman ang need ko. Pwede ko naman gamitin ito siya, yung dating ginawa natin, or pwede ito siya i-reuse. Ayan, para hindi na tayo paulit-ulit gawa na naman ng IC just in case may konting alteration sa gagawin nating devices. So, pwedeng parang mas madali na lang, pwede mong gamitin, kumbaga, pagde-design na lang ng mga circuits mo, pwede mong gamitin the same IC pa rin. So, reusability and modularity. Parang yung modular helmet na pwede mong tanggalin, pwede mo ibalik, or yung mga modular phones na pwede mong itanggal yung parts and then palitan, etc. So, paano siya na kahit na magbago ng konti lang yung design ko, magagamit pa rin siya. Scalability, ito yung dapat mabenta siya, kasi nga kung may mga future kang i-change, pwede pa rin siya magamit. Interface standards natin, we have a lot, yung mga output or input interfaces na pwede siyang paglagyan or yung parang makukonsider mo yung kanyang compatibility. So, we have SPI, IIC, ata yan, PCIe, yan sa mga computers, and USB ports. We have the next one, circuit design and verification. If you want to, make sure na yung design mo are really good, make sure na from the digital design pa lang, you use the following languages. Ayan. If you want to be familiar kung ano yung mga ginagamit, meron tayong electronic design, automation tools na pwede mong gamitin to analyze, to simulate, at saka to, make sure na alam mo yung output ng inyong mga i-design na IC. Analog designs natin, you have to consider the following parameters when you're designing analog circuits. So, for example, yung mga amplifiers natin, filters, oscillators, data converters, you have to, yung mga sinasolve natin sa communication class, We have the gain, the bandwidth, the noise, the linearity, at saka power consumption. Um, yung mixed signal design natin, I'm not really sure if I'm correct, but correct me if I'm wrong, yung substrate noise natin, yun yung mga parang impurities on the specific ICs that you use. Clock distribution is yung timing, on timing. So, if there are issues on the following, so you need to make sure na you check yung mixed signals natin. Especially if yung mga mixed circuits ang ginagamit. Design for testability, you need to create a plan na yung mga dinedesign mong IC would, pwede siyang i-test. Kumbaga, it can endure, may endure niya yung mga tests na gagawin mo. Kasi nga, pagkatapos mong gawin, I think may mga dying test pa naman yan siyang mangyayari. DIE, yung mga individual ICs natin in a wafer. Kailangan pa yan siyang i-check if it's working or not. So, dapat ma-survive niya yung test. Kasi nga, ang hirap naman kapag nag-test ka tapos doon lang siya gumana pagkalabas ng product, hindi na pala. So, let's avoid that one. Sa design process pa lang. So, you need to make sure that you design for testability. Physical design, yung mga layout natin, yung mga sinosolve na W over L, yung ni-report last time ni, I think it's CB. Ayan, so andito yan siya, W over L. And I think nasa problem natin, hindi ko lang lagyan ng solution or sample problem that talks about WL kasi nga, wala akong mahanap. So, sir, baka naman. Physical design, we have floor planning, placement, and routing. Parasitic extraction, physical verification, and leading to our mass data preparation or manufacturing. So, ito lang yung parang compressed version ng process in creating the IC. So, first, we have the tape out, yung mga geometric process, parang tinitape out or dinodrawing, kumbaga, sa layman's term, yan, para mas maintindihan nila, dinodrawing doon sa wafer. Wafer fabrication, yung parang ini-etch mo na, doping, yung parang sketch, tape out is like you're sketching, anong gagawin mo dun sa IC or sa wafer na lalagyan mo ng IC. Yung wafer fabrication, yun talagang paggawa mo na, nilapat mo na through the process of oxidation, etching, doping, metallization, etc. And yung next part natin is yung dye testing. Dye testing is yung sinusubukan, sinetest mo na kung gumagana yung kada units ng wafer natin. I'm not sure if lahat-lahat yun siya usable. Hopefully, kasi ang mahal daw, sabi ni sir, mahal daw yung kada wafer natin. Millions ang price. So, hopefully. Packaging naman, you try to encapsulate na. Yung parang, may mga layering kasi yan siya. Yung encapsulate na yung buong die ninyo para ma-protect siya, pwede na siyang gamitin in the circuit board. Ang silicon bring up, device characterization, and reliability testing, it will be under the validation. So, susubukan mo yung ICs mo, kung kaya niya ba yung stress, meaning yung weight, high temperature, humidity, anong klaseng stress man yung pwede i-impose sa kanya ng environment during the packaging, during the packaging, the transport, and then yung paglagay na talaga sa store, sa mga devices, or factory na kung saan ginagamit yung IC natin, yung mga devices, mobile phones, etc. You need to test kung gaano siya ka-reliable, kung gaano siya tatagal. So, ayan. So, different things that you have to do in trying to design and create or fabricate your circuits. So, ano ba yung mga key considerations natin throughout the process? We have 1, 2, 3, I think it's 7. So, we have power management. Make sure na konti lang yung power consumption natin. Very crucial yan siya na requirement. Especially yung for portable and energy efficient applications. So, hirap na naman naubos yung power ng phone mo just because yung icing ginamit is grabe mag-consume. High speed nga pero grabing mag-consume. So, hindi kaya ng ibang parts ng cellphone kasi hindi yun yung sumobra siya yung power consumption niya sa parang kailangan ng phone company. So, iwasan. It needs to make sure na manage or andun sa specifications na hinihingi ni client yung power natin, power consumption. Noise immunity, signal integrity, kung gaano ba kaganda yung quality ng signal, ayan, electromagnetic compatibility, cost optimization, design manufacturability, yung parang you have to consider yung limitations ng manufacturing devices mo just in case, or yield yung mga results ng mga manufacturing devices mo during the design process. So, you need to make sure na nakaset ako na dapat ganito kadami yung magagawa ko per batch, hindi pala kaya ng machine. So, masisira, sayang na din. At saka, yung medyo mahirap i-explain, intellectual property protection. So, you also need to make sure that you protect yung hindi mo ginagaya yung ibang design ng mga ibang ICs. You have to protect the unique design or aspects of your IC family. You need to register. Number one, you need to register the IP of your IC design, and you need to make sure na you also know na paano hindi gayahin yung mga IP ng iba pang IC design. If you're gonna be an engineer in the IC design industry. Okay, so we have here a short preview of the fabrication process. Ito, number one, yung wafer incoming quality check natin. That's the first step. And then wafer front side taping, turning over of the back side of the wafer naman. Ito yung mga individual steps wafer back grinding, backside metallization, optional daw siya. Backside lamination, optional din. Kasi usually yung sa front side lang naman yung ginagamit. Pero depende. Baka yung kailangan mong IC is dapat may backside. Depende sa pagkagawa or sa requirement ng design. Laser marking, again, it's also optional. But yung frame mounting, yung D-taping natin, kanina, nilagay mo yung taping for, the etching, etc. The metallization, ano pa ba? Ionization, nilagay mo yun siya kanina. Ngayon naman, tatanggalin mo yun siya. And singulation, yung pag-iisa-isa na, parang ready na siya para maging individual ICs, AOE, and then tape and reel. Nilagay mo na siya sa IC board. So, tape out, again, ito yung kanina, mass data preparation and manufacturing. And we also have, hindi lang naman siya theoretical or hindi lang siya more on explaining concepts. If you are gonna be an engineer, especially sa design, and you want, ito yung kompletong process ng fabrication ng IC. Ayan, or manufacturing ng IC. So, you have the following: wafer preparation, doping, photolithography. Ayan, yung sa light, pag-shape or engrave ng wafer through light, exposure sa light, kasi may mga chemicals na nawawala because of light. Etching, epitaxial, metallization testing, and last part is packaging. So if you wanna know more about those things, I found a really good resource for this one, yung IC fabrication parts natin, part 1, 2, 3. It talks about wafer preparation from the very beginning, yung sinaslice nila yung silicone strips, and then they also convert the sand into silicone wafers, and then yung paghiwa-hiwa talaga ng silicone wafer. So, pag-prepare ng silicone wafer for it to be doped. Ayan. So, i-ionize yung ibang part para maging NPN, PNP, etc. And through the process of photolithography, meron na siyang mga parts na natatanggal, na, yung mga layers na siya. Then, wet and dry etching. Although I will not be able to explain all of these types of etching. Siguro nakuha nyo naman siya sa electronics class ninyo, no one. And then the last part is yung video na to. Sa video na to, in-explain na kasi lahat. So, epitaxial, metallization, and testing, tsaka packaging. So, I think also Sir Gerald has a really good video, and he can share a lot about his experience in the industry itself. So, he has prior first-hand experience talaga, and he can explain more about those. But for me, I'll try to give you the key formula that we are using in IC design. So we have, for example, we have specific problems in propagation delay, maximum clock frequency. Sabi nga, clocking and timing kanina, one of the considerations that we have in designing ICs. We also have here, yan, yung mga formula natin. For example, the total propagation delay that you have is the sum or the average of the sum of the output transition from high to low na time at saka time for the output transition from low to high. So may mga ganitong klaseng formula tayo, and we also have here the maximum clock frequency. Ayan, so may mga critical path delay and synchronous circuit tayo. So eto with this problem. So ito yung sample problem natin. Sabi dito, a digital IC has a combinational block with a maximum propagation delay of 2.5 nanoseconds. The flip-flops, I think this is in computers, have a setup time of 0.2 nanoseconds, and the clock skew is estimated to be 0.1 nanoseconds. You need to calculate the maximum clock frequency for this IC. And if the technology node is scaled down daw, ayan, and the propagation delay is reduced to 2 seconds, may dalawang binago, what is the new maximum frequency or maximum clock frequency? So we have the following solutions for the said problem. Ayan, the first one is 357 megahertz, and then lumaki yung frequency niya because it was scaled down yung node, meaning mas pinabili siya, mas mahal nga lang, and then reduced to 2 seconds yung kanyang I think it was the 2.5 kanina. Ayan, so critical time or propagation delay is reduced to 2 nanoseconds. Okay, so we have also here for power consumption, these are the following formula and problems that you will encounter. So you have the static power consumption, dynamic power consumption, and I forgot to put here, it's not dynamic power consumption ha. This is the total power consumption. I'm so sorry about this one. This is the total power consumption. Okay, so for the power consumption, we have the problem, an IC operates at a certain voltage of 1.2 volts. Yan. Voltage supply natin yan siya. It has a static leakage current or I leakage of 10 nanoamperes and a load capacitance of 10 picofarad. The operating frequency is 1 gigahertz and the activity factor is 0.2. So we can calculate with the given information yung static natin, which is kanina, according dito, static is voltage supply and leakage lang. So yan, voltage supply and leakage, it is 12 nanowatts. And then we have here dynamic power consumption natin. We have the load capacitance multiplied sa square of the supply voltage, the switching frequency, and also the activity factor. So with that, we have 2.88 milliwatts as our dynamic power. And then you add them together for you to get the total power consumption, which is approximately 2.89 milliwatts. And for this one, ito yung sinasabi kong may width ng transistor and may length ng transistor. Gate oxide capacitance per unit area. We also have electron mobility, gate source voltage natin. We have the threshold voltage, the channel length modulation coefficient. Ayan, yung Y na baliktad. And we have VDS, drain source voltage. So if you wanna have a problem, solve a problem about that one, I think CB has provided a certain problem last time. And maybe I can provide one in the future, pero ang hirap ngayon maghanap, so maybe in the future. We have the next one. I think this is the second to the last topic and problem or key formulas that we need to discuss. We have the noise margin or the noise margin na high, yan, with your minimum output high voltage and your minimum input high voltage, at saka yung noise margin low natin, which has the maximum input low voltage minus our maximum output low voltage. So sabi niya, ano daw yung noise margin high natin with the following, ayan, logic gate that has the following specifications. So yung voltage high natin na output is 2.4. Yung voltage low natin na output is 0.4 volts. yung voltage high natin na input is 1.8 volts and yung voltage low natin na input is 0.8 volts. So we need to calculate both the noise margin noise margin high and noise margin low. So for this one, you just have to substitute in the formula. So lahat ng minimum, you add them together. Output muna before the input. So 2.4 minus 1.8 is 0.6 volts. Again, input naman dito sa kabila minus output if it's gonna be on the low. So input low voltage muna before the output. So OI sa kabila sa high, OI H HOI. HOI meaning high, noise margin high, minimum output. So that's HO, and then I, that's input high voltage, minimum input high voltage. So HOI, HOI. And we have here noise margin dito sa isa. We have NML or L I O, ang layo. Leo or layo. So we HOI, layo. Joke lang. Again, that's how I memorize kasi. So we have here the input low voltage na 0.8 minus 0.4 na. Output low voltage, we have 0.4 volts. And then the last one, if you're looking for the yield, yung results niya, yung output niya. So yield is equal to E to the negative ng chip area natin with the defect density natin. So if ang chip area natin, for example in this case, is 1 centimeter square, and sa kada 1 centimeter square meron tayong 0.5 defects. Ayan. Multiply natin yan siya, and that will be the exponent of our natural number na E. So we have here yield natin with the said problem sa simplified model natin. So we have 60.7%. And then on the new chip natin, just in case, yung where the area is reduced to 0.5 cm square instead of 1 cm square, it will now have a yield of 77.9%. So while the area is lumiliit yung area natin sa chip area, lumalaki naman yung ating yield or yung results o yung pwede nating makuha out of the design. So this is the last problem that we'll be tackling about the IC design examples natin. So again, if you want to know more about the said topics, I will be uploading the copy, and I guess that's it for designing IC families na report natin. Thank you so much for listening, and hopefully you've learned something. Bye bye.